of these, which is, okay, well, if we look at this first one, and then, did they say all the bulbs are identical?
Yeah.
Okay. So this total resistance is like, I'm just going to, what is this total resistance? 2R. Because they're both in series. So just add them. Over here, the resistance is R plus R over 2. So it's 3/2 R. Does that make sense? So which of these three has the biggest current? Yeah, do you see that this one is going to have, this I is going to be the biggest current? Because these currents, or these resistances, are all bigger than that. No? Yes? Okay. And if you then say that brightness is a function of power, so if you do P equals I squared R, and since all the R's are the same, does it make sense that that A should be the brightest? Let me go ahead and record this one. All of these R's are the same, so how do we know which one's the brightest? We have three choices of equations to look at it. Okay. Since all the R's are the same, I'm going to choose this, because then I can easily determine the current in each of these bulbs, and that will tell me who's the brightest. Does that make sense? So your statement was, if R is the smallest, that means it's the brightest. That's not something you want to remember, because in this case, it just so happens that because A, this one right here, was by itself, the overall R was the smallest, which gave us the biggest current. Now, the reason this one's the brightest is that when I take this current and square it times this resistance, that will be bigger than any of these others, right? Because the R's are all the same, but the individual R's. But when I use these total R's to get current, do you see how the currents in these two are, the current here and the current here is going to be less than the current over here? Well, no, we're saying P is the variable. That's the thing that's going to change. It's a dependent variable, right? And we're saying that the individual R's for everything is the same. So what is the thing that's going to determine the brightness? It's I, right? So then the I is what determines the brightness. So then us like condensing these circuits and finding the total resistance is just to be able to say, what is the value of I? How big is I for each one of these? So we know that this one, because the resistance was smallest, it has the biggest I, right? This resistance is bigger, so I must be smaller coming out of the battery. Therefore, this A must be less than this A. And this one, obviously, is the biggest resistance. So therefore, this has the lowest current coming out of the battery, and therefore, this A must be smaller than this one, which is smaller than this one.